Yeah, let's jump to another person that everybody knows, and that's Stephen Hawking. He took general relativity and special relativity, and he did something with that, and talked to us about his research and what he came up with.
Well, he had some help. George Ellis in South Africa and Roger Penrose at Cambridge and Stephen at Cambridge worked together over several years, taking those equations of general relativity and saying, what does that tell us about the history of the universe, and particularly the beginning of the universe? And it was in 1970 that Roger Penrose and Stephen Hawking published the first of the space-time theorems of general relativity. And the power of those theorems, they're based on two fundamental assumptions. Number one, that the universe contains mass. And both of us are living proof that the universe contains mass.
Right.
So that's rather trivial. The second assumption, general relativity reliably describes the movements of bodies in the universe. Today, we know that's correct to 15 places of the decimal. And so that's been established. And what Penrose and Hawking said, if those two things are correct, not only does the universe have a beginning, even space and time have a beginning. Space and time must be created.
Yeah. Now, why was it that Einstein didn't include time and space with his theory?
Well, he did. I mean, it is a theory of space and time and gravity. All that was in there. What Hawking and Penrose and George Ellis did is they simply applied what he had done, what he started, and said, let's see what else we can get out of this general relativity. And we've gotten a lot more since Hawking and Penrose about what general relativity predicts. We now have a good understanding of the physics of black holes. They didn't even conceive of black holes at that time. And so there's been a lot more development of general relativity since the time of Einstein.
He came up with a singularity as the beginning. What is a singularity? And talk about the ingredients that when he went back to the beginning, how he defined a singularity.
Well, lay people tend to define a singularity as when all the matter and energy gets compressed to a single point. A more accurate reference is when the entire universe gets compressed into an infinitesimally small volume. And that volume actually has 10 space-time dimensions. So think of something that's very squished together. That's the beginning of the universe. Space and time are created, 10 space-time dimensions, and it's expanding. And it's the release of space curvature. So as the curvature is released as the universe expands, that very quickly produces photons. The universe actually starts off dark, but by the time the universe is a trillionth of a trillionth of a trillionth of a second old, there's photons throughout the universe. And later, we get the particles that are responsible for the matter.